Thank you, Minister. Good morning, everybody. It's a real pleasure to be here. So I'm going to talk about the title which you see on the slide here, Will Society Adapt to Climate Change? And I want to start with this image of a very familiar and beautiful object. But of course, you can look at a picture through many different eyes. And I just want to draw your attention to this object seen through two different sets of eyes. One, through the eyes of a scientist interested in complex objects and how complex systems work. And this is something that has fascinated me all of my scientific career. And this object represents the most complex that we can study. It is the most complex object that we know of in the entire universe. And that's in spite of the wonderful talk that Thomas Henning and Lisa Kattenegger gave yesterday about the thousands of exoplanets that we know exist. But as yet, we don't know of any other object in the universe that has life. So to study this object, you not only have to have geologists and physicists and chemists, you have to have biologists and ecologists. But the very existence of the picture tells you that you need to have people who understand human behavior, because humans as an advanced species have been able to progress to the point where they could take this picture. So you need to understand economics, technology, psychology, and so on. And all of the different parts of the system, the atmosphere, the ocean, the ice, the biology, the people, all interact. We are one integrated globe. And indeed, the very famous British thinker, Jim Lovelock, has even suggested that we should consider this object as a single unified living organism of which we are all a part. So that's one way of looking at this object as an object of extraordinary academic interest and study. But we could also look at it through the eyes of a human being. And through the eyes of a human being, this is our spacecraft. This is our home. This is our life support system. And if you were on the space station as an astronaut, the last thing you would consider doing would be tampering in some way with the life support system that is providing you your oxygen, your water, your temperature control. And so we need to look at this object in that way. In fact, somebody joked once that there are many problems in life, but at least one gets a free trip round the sun every year. And so this spacecraft is carrying us, and it carries our destiny. Here's another image of that same object. And of course, if you look at it carefully, you see that there's something rather different about it. You cannot see the surface. And that's because this image is taken in a different part of the spectrum of radiation. It's taken in heat radiation. So it's looking at the heat that this planet is emitting into the universe. And of course, the way this works is that the planet gathers heat and energy from the sun. That energy drives the motions of the fluids, the ocean and the atmosphere, and indeed all of life, or everything that goes on the planet that is of interest to us is driven by that energy. But in the end, the planet needs to achieve an energy balance, a temperature balance, and so it radiates that energy away into space. And this image shows that the energy, when it finally leaves the planet, does so from high in the atmosphere. The atmosphere is actually opaque to that energy. And it's opaque not because of the nitrogen and oxygen of which most of the air that we breathe consists, but because of a tiny concentration in the atmosphere of what we call greenhouse gases. Water vapor, methane, carbon dioxide, and others. And it's that opacity, that cloudiness of the atmosphere, which traps energy near the surface. And it allows us to live, because if we didn't have that small concentration of greenhouse gases, and if that heat energy could radiate away from the surface, so that in this image we could see the surface, then the temperature of the surface would be 30 degrees centigrade colder than it is now. So rather than an average of plus 15 degrees centigrade, which makes it habitable for life, it would be minus 15 degrees centigrade, and the Earth would be frozen over, and we would not be here. So the opacity of the atmosphere controls the outflow of energy. Now, this figure 400 is very important. The amount of carbon dioxide in the atmosphere for at least the last 850,000 years, and probably for many millions of years, has just varied gently between 180 units and 280 units on a 100,000-year time scale, at least for the last million years, which is the natural rhythm of the ice ages. And so as the Earth cools to an ice age, the concentration of carbon dioxide drops to about 180 units. And then as we come out of an ice age to an interglacial, a warm period, which is what we're in now, much shorter than the cold periods, 10,000 years compared with 100,000 years. As we come into the warm period, various processes operate in this complex interconnected system that limit the amount of carbon dioxide in the atmosphere to about 280 parts per million. And that's been going on for a long time. But over the last 100 years, as humanity has, through science, technology, and economics, built the modern world using fossil fuels and powering it with fossil fuels, the carbon dioxide that we've released from burning those fossil fuels has accumulated in the atmosphere. It takes thousands of years for natural processes to remove it. And so we have increased the carbon dioxide content of the atmosphere to just over 400 parts per million. This is the first time in human history, and indeed even longer, that it has been at this level. So if we all take a deep breath, we're breathing an atmosphere which is qualitatively different and quantitatively different from how it was before humans and before industrialization occurred. So we have essentially changed a fundamental element of the metabolism of the planet. We've added a little extra opacity to the atmosphere. We've upset the energy balance of our planet. And indeed, that's why many scientists talk about the modern age, the modern geological age, as the Anthropocene, the age when humans have become a dominant geological process on the planet. So there are some consequences. As the energy accumulates, the world warms, ice and snow melt, sea levels rise, ocean and atmosphere circulation patterns change, extreme weather events increase, the water cycle accelerates, a warmer atmosphere can carry more water, a 1 degree change increases the amount of water vapor the atmosphere can carry by 7%. Ecosystems respond, life responds. Food and water supplies are affected, and people, all of us, are impacted. And what we know is that we're imperfectly adapted. Our modern world that we've built is imperfectly adapted even to the climate system that we inherited, let alone the one that we're provoking. So we need to be prudent and careful and think very carefully about what we're doing. So climate change can impact us both directly, but in a complex, integrated, globalized world, it multiplies other complexities and threats. And so it's often referred to as a threat multiplier. I'll give you one example. Between 2007 and 2010, there was a very intense and unusual drought in the Fertile Crescent where agriculture began in Syria. And this map shows the area, and the colored blocks represent the level of drought. So yellow is a sort of a drought, but not particularly unusual. Red is a very extreme drought. And then the brown colors are an extremely unusual level of drought, the sort of event that happens only once every 1,000 years. And that drought drove 1.5 million people from the land, from the rural areas, into the cities, where they joined 2 million people who had been displaced by the Iraq War. And so you had this massive influx into the cities, which was very difficult for the authorities to deal with. It caused civil unrest and dissatisfaction, which led to the clampdown and to the dreadful situation that we now have in Syria. And that in turn led to a flux of refugees. Now the question is, was climate change part of this story? And the attribution of that extreme drought has been calculated by the climate science community to have been 2 to 3 times more probable because of the climate change that has already happened in the area than if we had just left the planetary system alone and had not affected it, if we had not added that extra carbon dioxide. So although climate change didn't cause the problem, it made the problem much worse. And the problem we all know is very serious. Millions of people displaced, taking huge risks, many dying as they tried to cross the Mediterranean, and then huge problems in Europe as this massive influx of refugees attempts to find a new home and a new life. So the Department of Defense in the United States have been thinking about this some time, as have other strategists and military people. And in 2014, they said rising global temperatures, changing precipitation patterns, climbing sea levels, and more extreme weather events will intensify the challenges of global instability, hunger, poverty, and conflict. They will likely lead to food and water shortages, pandemic diseases, disputes over refugees and resources, and destruction by natural disasters in regions across the world. And this was written, of course, before the refugee crisis from Syria reached its awful state. Who knows if it's the peak? So this is all rather depressing news and very worrying, quite alarming. I'm trying not to be alarmist. But the good news you've just heard from the Minister is that truth has spoken to power. Science has spoken to world leaders. World leaders have considered the evidence and decided that it is significant and serious and that urgent action needs to be taken. And in Paris at 7:27 in the evening on the 12th of December last year, Laurent Fabius, the French Environment Minister, put down the gavel on the agreement of the Conference of the Parties 21. And the two key agreements that 195 nations have made is to aim for a common goal, that is to hold temperatures to well below 2 degrees relative to pre-industrial levels, and to pursue efforts to limit the temperature increase even to 1.5 degrees. We've had 0.9 of a degree so far. And also, in order to do that, to have a collective plan to stop emitting carbon dioxide into the atmosphere where it accumulates, and to do so to cut anthropogenic emissions and to achieve a balance with removals by sinks in the second half of this century, which is a fantastic diplomatic achievement, quite extraordinary, and everybody who was in Paris was euphoric about this wonderful result, that humanity as a whole, or the leadership, should agree to this important goal. What does it actually mean? Well, this graph shows year by year the amount of carbon dioxide that humans have emitted into the atmosphere. Now, of course, if we had just put some carbon dioxide in the atmosphere and stopped, the planet would find a new equilibrium, a new temperature equilibrium after 30, 40, 50 years. But we keep putting more and more and more carbon dioxide into the atmosphere, so the planet is constantly trying to find a new equilibrium. In the end, we must stop. And so the black curve shows what we have been doing up until today. The blue curve at the top shows where we were headed if no action were taken. This is what we would call business as usual. And this would have ended up at the end of this century with a temperature rise of around 3.6 degrees, maybe a little more, maybe a little less. There are always uncertainties in science, and this is such a complex object, it's very difficult to predict exactly what its trajectory will be. But the nationally promised actions that the 195 nations have committed to as part of the Conference of the Parties in Paris will bring that temperature down to about 2.7 degrees if they take all of the actions and implement them as promised. Well, you remember that the agreement says well below 2 degrees, indeed as close to 1.5 degrees. And it's the green curves that we will have to follow, the trajectory of our carbon emissions, if we're to reach those aspirations. So it is already a challenge to go from 3.6 to 2.7. The nations have thought very carefully about what they're comfortable in committing to and volunteering to. But there's a gap, a huge gap. And so what we see is that we're committed, if we're really to fulfill the agreement in Paris, to what many have characterized as the greatest collective action in history. And what it requires is that governments, businesses, commerce, and citizens the world over work together coherently to achieve this greatest collective action. Now, it's not easy. This problem has characteristics that make it one of the most difficult, if not the most difficult, that humanity has ever confronted. And it's as if a mischievous demon watching us had set us a particularly difficult task. Why is it difficult? Well, first of all, because it requires the rapid and fundamental transformation of the modern world. The energy supply, the economics, the politics, the infrastructures, and human behaviors. That's not a small task, that's quite a big task. And listening to Michael Sandel yesterday, we can see the direction that we need to go in, but we're way, way, way off course of achieving all those things. So that would be challenging enough. But we have inadequate societal instruments and institutions to address this. We have to invent all sorts of new ways that humanity can work together. And we have very little time. Changing human institutions, changing laws, changing politics is a slow business, so we need to move fast. There are vested interests. Many people are very comfortable with the modern world the way it is. I won't name them, you can think of them. And they're busy in attempting to impede progress, attempting to keep the world the same way because it suits them to have it this way. And then all of us, mentally, there's a disconnect. There's a tendency to feel, well, it's not now, it's not here, it's not me. I have my own problems to deal with. I need to keep my job, I have a family to look after, I have noisy neighbors. So we all have our distractions. And indeed, that not here, not now, not me is part of a deeper issue, which I've talked about, I do talk about quite a lot, not here. That is that our minds have not caught up with the modern world. Our technology and our science have raced ahead, but we still have the Mark I brain of the hunter-gatherer, and we're very sensitive to quick violence and danger, but we're very insensitive to what you would call slow violence, which is what climate change represents. I was director of the Science Museum in London for a number of years. And one of the privileges that I had as director was to be able to go into the archive, into the stores, where 96% of the collection are stored. That's not to say that the museum itself doesn't contain a treasure trove of objects. And as one looked at these objects and as one took down the technical manuals, there are 30 kilometers of library space with technical manuals in throughout the history of the Industrial Revolution to the present. And as one looked at all of this material, one was overwhelmed by the ingenuity of the engineers that had created the technology that underpins the modern world. And how many people in society are engineers and innovators? It's a tiny, tiny subset of humanity. And yet that group have an enormous productivity that had the most extraordinary impact on the world around us. So this is a very uplifting recognition. So what you see is that human ingenuity is unbounded. If we're given the right conditions and the right attractions, then we can make a difference. And so I've shown here innovative types of wind power, wave power, solar, of which, of course, Chile is very much involved, and nuclear power. Human ingenuity is unbounded, and so technology can make a big difference to this problem that we're confronted with. And we see that happening. The engineers are rallying, but we need a massive Apollo-like program. It's the equivalent of, more than the equivalent of putting a man on the moon. We need to mobilize the technologists. I have 4 grandchildren. I encourage them all to be engineers. And we see that the countries of the world are recognizing this, and there are 20 countries have signed up to accelerate the technological advances in green energy. This program is called Mission Innovation, and you can be proud that Chile is one of the signatories and one of the prime movers within that innovation. But of course, the big country that we need to watch is China, because China are world leaders in solar photovoltaics and DC grid. They have seen this as an opportunity. They have vast resources of people and finance. They have made a commitment that their growing energy industry will be 20% renewable by 2030. They will peak their use of coal. And that's the equivalent of installing 1,000 gigawatts of power. That's the equivalent of the entire power system of the United States. And they have committed to doing that in 15 years. And we know that when the Chinese commit to do something, they are confident that they can do it. And we know that they're aiming to do better. So this is an extraordinary example to everybody else in the world of ambition in the technological contribution to solving this problem. But in the end, technology won't be enough. It requires more. And we heard yesterday from Michael Sandel a message that essentially was telling us that we need to sanctify wisdom. We've all been drawn into this consumerist neoliberal world in which certain assumptions are made that the great decisions of state should be made on the basis of cost-benefit analyses and only cost-benefit analyses. And I reject that completely, and many others do. And Michael's talk yesterday encapsulated that view in a way that I've never heard before. It was wonderful. And of course, somebody who's playing a role in this was the Pope. The Pope published his encyclical last year, Laudato Si, and in it he said this: the most extraordinary scientific advances, the most amazing technical abilities, the most astonishing economic growth, unless they're accompanied by authentic social and moral progress, will definitely turn against man. So we not only have the technological challenge, which is big enough, but we have a fundamental societal challenge. How do we reintroduce morals and ethics into the world of politics and the world of decision-making in a way that moves human society forward so that we work together globally in a way that we have never worked together before? Another huge challenge. And then finally, already there is 40 years more of climate change in the pipeline. If humanity stopped emitting carbon dioxide tomorrow, the planet would not achieve equilibrium for at least another 40 years. And so we have to recognize that we have challenges already coming down the line to us, and indeed we're facing challenges from a changing climate. So we have to think of new ways of dealing with that. I'm responsible for a group in London that is attempting to make London the most climate-proof capital city. And the way we're approaching this is a risk management approach. What are the threats? What are the risks? How can we manage down the probability of a risk? And how can we manage down its impact? And how can we prepare to recover should that risk hit us? And this image of London shows how vulnerable London is to flooding. The floodplain is enormous. The floodplain has millions of residents, hundreds of billions of pounds of property, schools, railway stations, all of the heritage buildings of London. If you like, the lifeblood of London is at risk. But a group in the Environment Agency in London have developed what's called an adaptive pathways approach to deal with this. They've said there will always be irreducible scientific uncertainties. We will never know exactly what the future will bring. So we'll embrace that, and we will put together plans for a range of eventualities, and we will make decisions accordingly. And if we find that we've got them wrong, we'll adapt accordingly. This is a very rational and logical way to deal with the adaptation. So I'll finish by a quote from Samuel Butler, who is a British Victorian thinker and writer, a futurist, somebody who thought about the future and thought deeply, and was very interested in Darwin's theory of evolution and didn't necessarily completely agree with it. But he gave this interesting insight, which has fascinated me. As a physicist, I'm always looking for underlying principles. And Butler said, all progress derives from the ineluctable desire of every organism to live beyond its means, which is quite funny, actually. If you think of managing your finances, you always want to spend a little bit more than you can really afford. And so this grand challenge that faces us is that humanity has to manage that desire. We have to manage our desire to live beyond our means, and we have to do it voluntarily and fairly and globally. And maybe because of our intellect, maybe because of our capacity for rationality, we will be able to do that. I hope so. But if you think about Butler's quote, it actually says something rather deeper than human nature. It's actually a comment on nature, on biology, and how biology progresses. And if that's so, then it means that the challenge is not just to overcome our own nature, but to overcome a basic principle of the way life evolves. It's as if we're looking at a book and we don't know what will be written on those last pages. In 50 years' time or 100 years' time, what will those words be? They could be a success story. We could be looking back with satisfaction on having collectively grappled with this problem and solved it, or at least done our best to solve it. Or it could be very bad news. Indeed, there might not be any words because there might not be a stable civilization in which they could be written. But one thing's for sure, and that is the writing of those words is something that you and I and our children and grandchildren will all do together. So my message at the end is that the future, what kind of future do we want? The answer is, it depends on us. Thank you very much indeed.